You have probably heard before that Gauss, when he was a little kid, he was asked by his teacher, just to kill time, to add up the numbers 1 through 100. And instead of doing that menial task, Gauss actually came up with a proof of what is a formula for the numbers 1 through n. And he did that as follows. He wrote the sum 1 through n, and then wrote it in a different order, and then added up all those numbers so that twice the sum he was looking for is just n times n plus 1, so that the sum is n times n plus 1 over 2. So this is a cute proof, but what can we do with it? Why do we teach students these elementary proofs? We do that so that you can adapt this idea to prove other things that are similar in nature. So let's do just that and prove something else using the same idea of Gauss. Let's find a formula for the sum of the first n odd numbers. So I'm going to follow Gauss's idea and add them up in the regular order, and then in reverse order, starting from 2n minus 1, the next odd number would be 2n minus 3, 2n minus 5, and so on, and then add up these two lines. Now, the sum here is clearly 2n, the sum here is clearly 2n, 2n, and 2n, so it's 2n everywhere, and there are n numbers, so there are n times 2n in total. So if that sum is s, then this is also s, and this tells me that twice s is n times 2n. So what we get is that the sum of the first n odd numbers is n squared, is a square. So the sum of odd numbers are squares, 1, 4, 9, etc., which is something very cool that you might have seen using, for example, induction, but here's a direct proof of why that works. By the way, you can use the same trick to add up any arithmetic progression. By the way, there is a nice way to visualize why adding odd numbers give you squares, because when you add to 1, add 3, you complete to the next square, and then you complete to the next square, and you complete to the next square. So you can actually also prove that the sum of the odd numbers are squares using this idea.